All right. Welcome back to another episode of Composites Weekly. Today I've got Pravin Luthada of Addcomposites. He's joining me. We're going to be discussing some of their technology as it relates to AFP. It's amazing some of the work that they're doing right now. Addcomposites aims to become the go-to provider of advanced manufacturing solutions that enables widespread adoption of composites. They design reliable and user-friendly advanced manufacturing systems that provide opportunities to integrate composites into their production. As many of you know, are familiar with AFP technology, automated fiber replacement is an advanced manufacturing process primarily used in aerospace, automotive, and other high-performance industries to create composite structures. So I've got Pravin on today. He's going to be sharing a little background on himself, the company, and some of this, the technology that they have that can be actually retrofitted onto existing robotic systems within a plant that can offer a lot of cost savings to companies that are wanting to basically, adopt the AFP system. So, Pravin, I'm pleased to have you on the show. Thanks for spending some time and joining me on Composites Weekly.
Thank you, Jonathan, for having me. A really great opportunity. I've been listening on to all the episodes, so thank you for having me. Yes,
absolutely. It's great to finally connect. I know we've connected briefly on Modulus and LinkedIn, so it's good to have you on, and I'm excited to learn more about what you all are doing. If you would maybe start with yourself before we get into Addcomposites. Talk about yourself. We were talking briefly before the show started about your background in the aerospace industry. So if you would share a little bit about that.
Yeah, so I started my background is in the mechanical engineering, and then I started as a scientist in the Indian Space Research Organization, mostly focused on satellite and launch vehicle structures. One of the famed mission, what I would say, I was part of the moon orbital mission from Indian Space Research Organization, where I was one of the engineers on the panels that we made with composites that made it to the moon. And
awesome.
yeah, but I realized then and there that there was the problem with composites manufacturing was that I was spending more time in the meetings getting approval for the parts than actually designing and producing them. And the only way that I could see was to solve it with the automation. And I raised a tender, and I I looked at the prices, and it was just crazy. So I decided that that's a good opportunity to jump off and do my master's. So I moved to Finland, started my master's studies, and really found a really good set of friends here within the university who also were really thought that this is a very good problem to look at and how can we solve it. And we looked at how can we make automated composite manufacturing in every workshop possible. And yeah, that's how Addcomposite got started in the university, in Aalto University here in Finland. And that's kind of my background and the company's background, how it works together.
Yeah. Sure. Yeah. I mean, it always starts with obviously a problem out there. And what is one of the biggest barriers of entry into, automated composites is the cost, right?
It is the cost. The capital cost is just insane, and then the lack of know-how, I would say, is the second most. So because people do not have access to this, they do not have an understanding of how they can design with it. So it's just these two kind of commingled challenges. If you don't have it, you can't, and then because it's so expensive, you can never have it. So it's never going to expand.
Yeah, absolutely. Well, I'm fascinated by some of the technology. You're going to be talking a little bit about some of the capabilities that you all have. Let's get into some of that. I mean, I've spent time looking at mostly this AFP XS, which it feels like it's more of a kind of a plug and place technology, and you can convert most robotic systems into an existing AFP. So, I mean, that's pretty amazing. I mean, talk about cost savings there. Explain, if you would, that technology, how it works, because I think you guys, it sounds like you supply not only the hardware, but also the software for that.
Yeah. So the idea also, as I said, the accessibility was the main point, and we wanted to figure out how we can get this in every workshop, in at least every composites workshop out there. So we were like, the robots are getting pretty ubiquitous, and how
Yeah.
could we leverage that as a platform to build on top? And when we started, we wanted to keep the first step to move towards it was really low. So we started with the building the hardware that could just attach and
Hmm.
work from there. And then we looked into some of the software as well, which was very expensive and very, you could say, wall guarded. So we wanted to also make sure that we use like an open source platform onto which we could build and then also provide it to all the users. So both of these combined together, we build a kind of a technology stack that plugs into what you would call like standard robots communication protocols,
Hmm.
and basically converts them into a full-fledged AFP where you have capability to not only control all the AFP related systems, but gather all the process data at the same time while not losing the aerospace accuracy that we need to have. So in composites, you want to make sure that the quality is going to be the top notch,
Sure.
and achieving that took us like about 4 to 5 years of just going through the building this technology stack. Yeah.
Yeah. I mean, how long is that? I mean, from startup that you all have been in development of this. I mean, your company's how old?
So right now we started like formally we established in 2017, but before
Hmm.
that 1 year we were in the research project phase. So about
Sure.
so like 4 plus 4 now. So like now about 8ish year to come.
Yeah.
We since we started actually on the project, and I think we sold our first system just right at the beginning of COVID, you could say. So like 2019. So
Wow. That's perfect timing right before, right? Yeah.
yeah, just right before. So we could not travel for installations, even though we have the systems and there, but we could not travel for installations.
Yeah.
And then we built this approach even that we could remotely install the systems, and we don't even had to travel. So it was quite wonderful overall that experience as well.
Oh,
That
that's
taught,
great. So
yeah.
that's pretty standard right now. You can work with most of your customers remotely on
Yeah.
issues. Yeah.
Yeah, so the system is built in a way that, like how you could do over-the-air updates on everything. So we have
Yeah.
over-the-air update for software that goes out every month, and then over-the-air update for the firmware of the system, because we are constantly evolving, and we have now close to 50 systems out there in the
Hmm.
world. So we get constant feedback from all of them, and as we work through them, we improve the firmware, and we switch all the systems also get that updated into them. So now the feedings are better, the beginning accuracies are better, the
Hmm.
approach and how it handles the different curvatures are better. So all of that get pushed
Yeah.
out. Yeah, yeah.
So I know there's a lot of applications that you could use, AFP for. I know typically you see it a lot in aerospace. I mean, what are some of the industries? I'm sure that you're working in that field, but any other type composite companies or industries out there that you all are seeing that are interested in adopting this technology?
Yeah, so from our standpoint, what we did very well was that we work with technology partners who are kind of working as the first point of any
Okay,
new product development.
sure.
And because of that, what we saw that we worked with the space industry to begin with, then aerospace, then defense,
Yeah,
and then we have customers in marine and also in wind energy,
yeah.
which is what we don't see in typical AFP technology. And given we just started to sell the system, like kind of you can say mid of COVID,
Yeah, right, right.
so and having 50 systems, that kind of made us show that there is a huge need for such system in the market in
Mhm.
all industries across, and I would say including automobile and sports industry, where we constantly have this very engaging discussions where they are still they want to actually use the material. They're just figuring out, okay, how could the system be made to work for that particular application.
Yeah.
And that's where I think the platform, this AFPXS platform, is very useful, because it not only is able to work with thermoset, thermoplastic, or dry materials, it's also able to work as a filament winder. And then it could also work like just, with the 3D printed tooling, to then you have like, you want to just have a single skin core, and then you do the placement and such. So you can combine so many ways to build the composite with this approach. And even if you have new materials that you want to experiment with, so that is all allowed within the system, and that is just allowing us to be in all these different industries.
Yeah. Yeah. So how do companies that you work with, how do they verify, I guess, the manufacturability of parts that they're looking at using AFP technology? Do you guys, I'm sure that you have a consultation with them, obviously, since you all designed the software.
Yeah.
I think that probably plays a big part of that, is determining whether this is the right fit for their application.
So we built this like going a bit in the software, we built the software stack now very well. So it kind of talks to the design software, as well as within the manufacturing, it can predict the defects already beforehand. So let's say you have oversteerings or gaps or overlaps happening in certain places, and how should you optimize that design? So whenever a customer request comes in, it just like, we do this free of cost for all the discussions we have in place. We do the free simulation work for them. So we have an engineer on site who basically is just doing that. So it's just like, okay, getting, the typical standard practice, getting the NDA in place, getting the CAD from them, getting the placement simulation ready, and sharing with them the file so they could see this. And then we invite them to the facility if they would like to see. And because we have so wide range of systems available pretty much everywhere, we can also just ask them to visit the nearby facility, where we then say, hey, this is the nearby technical center which has the system that they could host you. And then they also get the would you say industries are able to then go more to nearby technical center where they can build this good collaboration as well. Yeah.
And how many of these technical centers are there?
There's quite many. I actually was not of that.
How many in the U.S.?
I think we have about 10-ish system in US,
Okay.
And then I think 2 systems or 3 systems in Canada. So yeah.
That's great. And you mentioned, I heard you mention thermoplastic composites too, capabilities in that arena.
Yeah.
If you would talk about that, that's exciting.
So thermoplastic, I think for us, it got the main attention because it was the sustainability that was driving that trend, and it kind of peaked when we actually started the company. And early on, we were requested to have this capability. And fortunately, we found like this flash lamp technology, which was at the same time also was in the stage of entering into the market. And then we collaborated and we showcased how easily you could then make any robot into actually thermoplastic cell as well, because now you no longer need the cage. In lasers, you need these safety cages, otherwise you're not able to operate. But with this flash lamps, you're able to do that. These flash lamps are relatively slower, but it's actually better for your thermoplastics. So because it allows for diffusion and good bonding with the system. And I think so we are able to not only work with this type of system, but also have the laser system wherever the industrial use cases are needed, where you would want to go really fast, and they are more comfortable having a laser cell as well in the facility. So many of our customers, even they actually had pre-owned lasers. They were like, hey Pravin, we have this laser, can Addcomposites AFPXS have this in used in their system? And I was like, yes. So if they also have pre-existing heating units, that we could integrate into the system and provide the system with that. So the goal is still, as the baseline comes down to, make it really accessible, make sure that the applications keep developing, and once it gets in the hands, I have seen beyond my imagination what the the ecosystem have come up with. People are so talented. It's just great in the ecosystem.
Absolutely.
Yeah.
What do you think is a driving factor we mentioned cost. Obviously, that's a big one, and the advantage that you all provide. But people that are looking to adopt the AFP, a more automated approach, is it? Is it, does a lot of it have to do with finding qualified or looking ahead to, I guess, worker retention and being able to find qualified people out there and instead have a process that you can rely upon that is pretty seamless and consistent all.
Yeah, I would say kind of all of those elements definitely play a role.
Yeah.
From the discussions that we have had, so there are types of material, especially let's say if we start with thermoplastics. You cannot do a hand layup for a thermoplastic part, so you
Yeah.
are bound to go in some automated fashion
Sure.
to use this technology. And the way what we have seen, kind of the because we have the possibility to go thermoset and then thermoplastic, so
Right.
it kind of adopts to the existing products, and then there is a flexibility to try out new things. And that is the one of the key drivers what we have found that the composite manufacturers really want to get into, because this is kind of future proofs them
Yeah.
against the upcoming trend. They can also take on some very exciting projects which are not AFP but something related to winding, but they don't now need to have a winding setup. It
Right.
could do filament winding for tanks as well. And you could not only do just thermoset or dry winding, you could do thermoplastic winding, which is
Okay.
then opens up completely new area for you to do like some electric motor sleeves or hydrogen tanks or such.
Yeah,
So
I was
then,
going to ask what the capabilities on filament winding.
yeah.
You can go all the way up to utility poles, all the way up to tanks, right? I mean, large tanks.
Yeah, large tanks, small tanks. You could go really long, like structures
Yeah.
on boats, and then, yeah, I think poles and such. And the main benefit here, what AFP brings along with the filament winding, with the filament winding, you have to go over the dome because you want to follow a geodesic path. But here with AFP, you could just go zero direction along the axis,
Okay.
just cut the fibers, and then you could do all the plus minus 45s without having a build up onto your polar regions. And then you could optimize the design of the tank that exists today at least by 20% in terms of weight saving, just by
Wow.
having that as a capability. So it's just, I think, and these possibilities is what is the key driver. Coming back to your question, is because you are able to have all of these venues open, it basically opens up a business coming in, like what you could do, because the know-how is there. This
Mhm.
just opens up that capability to be offered from the center. Yeah, yeah.
Yeah, and if you already have if you're already using robotics to some degree in your application, obviously you're geared toward this anyway, right? I mean, you're adding to existing technology that they already have in place.
Yeah, that reduces the infrastructure, you can say the workload and the cost. So
Of course.
mainly, let's say if you have a CNC robot that you were using for some polishing purposes or
Mhm.
such, you could mount this onto that. And then we are trying to grow like in all different brands of robots. So, and
Mhm.
gantry as well. So you don't have to be limited to the 6-axis robot. If you think the majority of the parts that you'll be doing is going to be requiring only like a 5-axis CNC, why not just go and have this? It's a very compact unit. It weighs barely like 12-15 kilos. It
Yeah.
could easily mount onto any of the 5-axis and do the job.
And you say easily, I mean, it's pretty, because if you're tying up a robot, or if you have a robot system dedicated to, as you mentioned, polishing or some other application, uh, to switch back and forth to add this technology on is fairly
Fairly
easy.
straight. Yeah, you
Yeah.
could have like a quick connectors. You could do it like within 5 minutes
Wow.
automatically or such. But then if you, that's the beauty of having it compact and everything there. It just makes it so much more easy to
Yeah.
get more out of the robotics setup that you have built in the company. Yeah.
Sure. Fascinating. Pravin, this is incredible. Where can we have your website up? Where can our listeners? I want to mention where they can find out more. It may not be the website; it may be other locations, or we just may want to send them directly to the Addcomposites website. But I'll let you take the lead on that and let them know where they can go to find out more.
Yeah, so they can definitely reach out to us. We are quite active on LinkedIn.
Hmm.
We make sure that we post every day
Yeah.
something exciting in terms of research articles or blogs that we find that is happening within the composites ecosystem. And they could definitely reach out to us from like at Composites website, just at composites.com. And there they could directly click on a button, fill up a form, and they will get the quotation for every element that they would like. Even if they would like to just get a robot, just get the AFP system, or just get a filament winding system for
Yeah.
themselves, yeah, they could
That's
already
nice.
start to budget this out. Yeah,
Yeah, that's great. I'm assuming you'll be at Camex. You guys will be at Camex, or
we'll be at Camex, so we
okay,
have our Canadian partner, B-Spline, joining in as well there. Yeah.
okay, very good. And how was Jack World this year for you all?
It was quite exciting. I was so surprised that 3 days it could go so fast. So
Yeah, it's a lot of build up, and then it's kind of like Christmas, right? You build up all
yeah,
year round, and then it's like, okay,
yeah,
it's
now
gone.
it's gone. Yeah, now you have to take the tree down. It's
That's
just
right. Pravin, thanks so much. I'd love to. I want to stay in contact with you, and definitely have you on the show floor when we're at Camex. We'd love to invite you, or if you're not going to be there, somebody with Addcomposites to come down, and we'll be doing a lot of interviews on the show floor at Camex this year in September. For a couple of days. And so definitely would love to invite Addcomposites to come down and do a little follow up with you guys and see how things are going at the show.
definitely. Thank you for the opportunity. Would love to be there. I think either myself or James, my colleague, is actually from US, he will be there definitely, and would love to join. Yeah.
Very good. Well, we'll communicate, stay connected. That is Pravin Luthada of Addcomposites.com. And we'll be posting a link on our show page for this episode. And be sure to share also their profile on LinkedIn, where people can learn more and connect with their company, and Pravin as well. Pravin, thanks so much. Have a wonderful weekend. And I do appreciate your time today on the show.
Thank you. Thank you, Jonathan. Thank you, everyone, for listening. Thanks. Bye-bye.
Absolutely. All right.